Alrighty, welcome everyone to day 18 of Advent Code. I opted to get some sleep last night, so it is the next day, the afternoon, but we're gonna get into this either way, so let's do it. You and the elephants finally reach fresh air and emerge near the base of a large volcano and seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and towards the ocean. Bits of lava are still being ejected towards you, so you're sheltering in the cavern exits a little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing and as it solidifies. Depending on the specific compounds, lava, the speed at which it cools might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets, so you can take the quick scan of the droplets that flies past you. As for puzzle inputs, because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of the lava droplet with a 1x1 cube on a 3D grid. Each approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube, so if you're scanning okay. After counting up all the sides are connected, total surface area. So what's the surface area? Okay. Gotcha. So, yeah, the best way to do this, it could be to throw this into, it's a 3D cube, could be to throw it, I mean, there's only 2,000, I guess we could throw them all into a list. And then just go one by one. I mean, let's just do the slow. Let's just do the brute force. It's not gonna work for part 2. I can almost guarantee you this won't work for part 2. But we can at least do the brute force. So it's gonna be a list of 0.3 cubes for string s and inputs. What do we? It's just that. Okay. So I have s dot split on comma, and then cubes add 0.3 sorry, new 0.3. What is, did you take in? You do, yes, thank goodness I made that method to just take in this. Nice and simple. Oh, new instance, ha. That's why. There we go. Okay, so that makes cubes there, and then we just brute force this and do int sides equals 0, 4.3 cube and cubes. We just now got to go on all 6 directions. So 0.3 just do off equals new. Oh, we can add. Oh, okay. Let's do this then. So we can do a list, private static final list. This is gonna be 0.3. This is gonna be directions. As list. Stirs like this. New. 0.31000. Oops. And now we just need all 6. -1, 1, -1. Oh, I did too many. And 1, -1. There we go, there's all 6. Now we have these. Now we can actually just go into here and do 4.3 dir and dirs. Add this 0.3. It's gonna be cube. Add direction. This returns a new one, right? Yes, good. Returns a new one. And we can just now check if cubes contains direction sides plus. Sorry, so if cubes does not contain this direction. Oh, sorry. offset. And go ahead and lap on sides. And in theory, if I did this right, if I also don't forget to do day 18 here. In theory, now if I run this, we get an answer. And that answer is good enough for 1 star. Alright, let's see how badly this is going to fail us for part 2. So this is off by calculation. The cooling rate depends on the exterior surface area, but calculation also includes the surface area of air pockets trapped inside the lava droplet. Instead, consider only cubes that could be reached by the water and... Okay. Oh, maybe this won't. Maybe not. Okay, okay, we can do this, not too badly. What we're gonna do is we're going to go through all the cubes again, but we're gonna do this as a sort of flood fill. Basically, we're gonna go off all the edges and we're gonna remove all of the cubes. We're gonna probably not remove all the cubes. Well, we're gonna have to add cubes. We're gonna have to simulate and add cubes. Okay. Okay. I'm trying to like plan this out here. So we're gonna do again here, and we're gonna need a method of we probably do this in one method. What we need first, actually no, what we need first is we need to know all the mins and maxes. So min x is going to be equal to cubes. Let's just stream it. I'm lazy. Minimum of a dot x minus b dot x. I'm not sure if that does any smaller or any less, but okay. Min y, min z, y, z, y, z. Let's take also y. And then these are going to be maximums. That means this needs to be max, max, max. So using these, go through all the points, and what we need to do is we need to make sure if we go off in each direction that it doesn't reach another cube. If we hit these, if we go beyond these min and maxes for a cube, we know it is in the middle, and so from there we can flood fill it. We also need a list of cube, no, point, sorry. This is going to be visited. Because we might visit other cubes while we do this, so we don't want to double the logic. Because if we find a pocket, this pocket's going to find the rest of them in this. So we don't want to do multiple of these. Nope, continue. Okay, so what we're gonna do now is for this cube, we're gonna go off in each direction. I'm gonna need to make this into a min maxes. It's gonna have to match this. So max x, min x, right? Max y, min y, and then max z, min z, just to make sure. Yeah, okay. So then for int I equals 0, while I is less than directions size I plus plus. So now we are going to then do a we need a direction. We need to go off. So we need 0.3 offset equals cube. Can I just pass cube in? Does that? No. I don't have a. Okay, fine. We'll do this way. So we have our offset, so we can then do while. Oh, but I don't know which one we're accessing. I guess I can just check them all. So I guess first I can do is while offset or while cubes does not contain offset. I guess we need to offset it. I guess we do while here. Cubes doesn't contain offset, and offset dot x is greater than min x, and so I guess we didn't need this because as long as it's within the realm of the cubes, it's fine. I guess it should be greater than or equal to, less than or equal to. And do this 2 more times. This is gonna be y, 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 z, z. Wait. Oh, I said do z before y. Okay, sure. Z, z, x, x, sure. So now we can do is offset equals offset dot add ders get I, and that's it. So this works. Then all we need to do now is we need to determine what is happening. So if we are outside, so basically all we care about is, does cubes contain this offset? If it does, we've hit another cube, which is what we want. So boolean pockets equals true if, no, this goes in here. After this while happens, if cubes contained, or if cubes does not contain, that means it's one of these, which is all we care about. Then, I guess, sorry, if cube contains, that means pocket is false. And we can then just break. But if these all go through and we have found a pocket, what we need to do now is technically flood fill. which I guess could be done. No, it's not quite doing a flood fill. But what if, I guess we don't want to care about optics. What if we have a cube, you know what? I'm going to do this differently. I'm going to leave this for a second because I might need this. Instead of doing this, we have a box we can check. If we go through every one, we check the ones that the cubes, if it's not, doesn't already have a cube, we check that one, go out in all 4 directions, or all 6 directions. That might actually work better than this, because that then removes the case where we have a cube where one side of it is not in a pocket, one side is in a pocket. This might work better. Let's do x equals min x while I is less than or equal to max x, I plus plus. Oh, x, not y. Oops. There. Y, Z, 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 and don't forget these to be Z's as well. Okay. So now what we can do is, we don't care about visited per se. Actually we do care about visited. X, Y, Z contains P, or cubes contains P. Skip over because we don't care about one with cubes. We just wanted to do it from here. And so now we can do this again. Pocket is true. We don't need offset. Actually, we should do offset. Move on to the next direction. What we want to do is, yeah, that's fine, because if it gets to the cube, it's fine. We just want to make sure that each edge hits a cube and that none of them hit the bounding box area. Cool. So then we should do let's do system.out. Print line pocket at p dot toString. It's offset. Yeah, p. Yeah, okay. All right. So if I run this, if I get it the example input. So we should see one pocket with this example input. What's my error? I need if pocket. Whoops. Pocket. If I run this, please give me a pocket. Pocket at 1, 1. Oh, well I got 2 pockets, but neither one of them is the right thing. Okay. What? Something's wrong. What's in cubes? Z is 5. Something wrong with Z. Why is the Z not working? Because I didn't change these to Z and Y. Oh. Well, that might have been a big issue. Sorry, it's P equals new 0.3225. All right, this time give it to me. Hey, we finally hit it. Okay. Okay, we've been finding a lot of pockets. Oh, wait, why did this get flipped? It does work. Sweet. Okay, so we found our pockets. So we have our pockets. So this pocket is true. So now if we have a pocket, we need to now flood fill from that spot. Okay, so we need is a list of 0.3. This is our queue. Our queue, and all we care about is adding 2 cubes. So everything we find in this pocket, we add to cubes. And also add, well, it doesn't mean to give visited. We don't care about visit anymore because visited is cubes. If we visit it, we put in a cube. So we don't care about visit anymore. So Q add P, and then while Q size is greater than 0, flood fill this area. So point point equals Q dot remove 0. 0.3. My bad. And then for directions in this, point add direction if cubes contained, oh wait, I should do this. If cubes does not contain point, cubes add point. And then again here, technically I don't need to do this in both cases, but we're just to avoid duplicates here, then just be able to do these all. Whoops. Point equals, I can't do that. I need to do a new point 3 offsets. But this isn't added to cubes, this is added to queue. And that should do it. So what should happen now is that I can now do this and count sides. I'll make this a method here. Private int get surface area. Cubes. Return sides. Good surface area of cubes. So this is part 1. And here is part 2. Please work. I think it's still the example input inside the test. 68 and 64 and 58. Hey, that is right. Sweet. Oh, it's so nice to finally be able to solve problems again. Oh. Well, so I don't know what I did. I was playing around with actually outputting each layer here. That way I could just kind of visually see and maybe help me debug, and it just finished executing in less than a second. And I got my answer. I don't know if I changed something or what, but I guess if I remove that, I can now remove that. And yeah, I don't know. I don't know if I don't know if I typoed somewhere or whatnot, but anyways, it works. There we go. That's I submitted it and I got it right. That's part 2 done. and that is day 18 done. Wasn't too bad. Part 2 wasn't too bad either. I just, for some reason, my code just didn't want to work until I changed nothing, or I don't know. But yeah. So explanation. Today's is we were given like this water drop was what they called it, but basically this ball of object, and for part 1 we needed to count the surface area. The surface area of this is any side of the cube that is facing open air. So it's easy, pretty easy to brute force. We just import it. I just imported to make this big list of 3D points. Then we count as we go through each cube, go in each direction of the cube, so you know, up, down, left, right, forward, back, and we get each of the points here, and then we simply just check if that offset is also within our points. If it is, that means it's another cube, so that's not an open face. If it's not in that open cube, or if it's not in their cubes, it is an open face, so we just increment signs, and we do, and that's return for part 1. Not too bad. Part 2, though, we get a little more complex, and that's now our ball of cubes. We now know that it has air pockets inside of it, and so we need to kind of determine if it's an air pocket versus the actual outside of the droplet. The way we do that is essentially we just take our droplet, we put it into kind of a box by getting the minimum of all the x, y, min and max of all the x, y, and z positions, and then iterate over every single 3D point in that box. We make sure that we're not in a cube that we already track. So if it is, we just skip over it because it's, you know, it's already a cube there, don't care. But then we try to figure out if the specific point is in a pocket. So the way we do that is we just extend from that point out in all 6 directions, and we try and hit another cube in our droplet. If we do, we know we're inside of it, it's fully contained within the droplets. If it's not, it'll hit the extremes of the min-max or whatnot in both directions. That means it can see the edge or can see the outside, so it's not inside a pocket. If we determine it isn't a pocket, all we do is we just flood fill from there. So we start at that point, we add that point to our cubes, and we just keep flooding out. We keep, you know, adding all of its each side of it to our queue, keep adding and adding until we get to the point where we can no longer add any more cubes from this point. Therefore, we've completely filled our air pockets, and now we can continue on. So basically, what we're doing is we're just making our droplet solid. It doesn't matter about those air pockets, we just want to make it solid. That's all we do. And then once we make it solid, then we go through, add up all the cubes again, same as part 1, and output that. And there we go. That is day 18 done. Hope you guys enjoyed. I'll see you guys all tomorrow for day 19. Peace out.